Good morning, student. In today's class, we are going to deal with the concept of your FPGA, right? In the yesterday's class, we have talked about what's the CPLD. In today's class, we are going to describe the architecture and the block diagram of FPGA. What is FPGA stands for? It is nothing but Field Programmable Gate Arrays. So basically, what is FPGA is going to be explained. That particular part we are going to cover in today's class. So before proceeding with that, let's take a previous class overview what we have discussed. In the previous classes, we have talked about SPLD, that is Simple Programmable Logical Arrays. Then we have discussed CPLD, Complex Programmable Logical Devices, and then we are going to proceed with FPGA. So what is FPGA stands for? FPGA stands for Field Programmable Gate Arrays. So this is nothing but this has been designed by the Xilinx. So who has explained this? This is explained with the Xilinx in 1985. They have described the first commercial FPGA that would be useful in designing the VLSI part. So it is useful in designing the VLSI part, and the most important part which they have explained about FPGA would be they are going to explain a device which can had a good density performance, and it will take the less power consumption, and it can take the maximum of 40k system gates. Means it can take the gates, whatever the gates we are using. The name itself would say that it is a programmable gate arrays. Gate arrays in the sense it take the all types of logic gates. So initially when they explained in 1985, they have taken the 40k gates, right? That means these number of gates we can able to take it, and we can able to do the programming to it. Then we can able to write that particular gate function based upon it the capacity. But as soon as the development has been increasing, so what they did, they try to increase the capacity towards the number of gates arrays. So they have improved that one in this pattern. That is also they did. So initially they have taken for 40k. So that would be the things. Next thing, what is the improvement they did? They have taken a good density. Density they have increased the performance of the system as we are enhancing the quality. So the performance also has been increased. The next, power consumption. So the main criteria for any kind of electronic device or any kind of programming device, if you want to go for hardware part, the power consumption needs to be as less as possible, because we want to give less power, we want to get the more output. That are criteria whenever we are designing any kind of device. So here, so density they have increased means the capacity of it, the system they by day they are increasing. So the next thing, the performance. Performance means the what kind of and what time delay and what how do they are going to produce the output, that adds to be improved. Next thing, the power consumption. The power consumption needs to be improved and there needs to be enhanced. So these are them. There are many what we can say features for it. So out of that, this is the basic 3 features which I wrote it. Now proceeding with the basic Xilinx architecture, how the Xilinx architecture has been designed, that particular part I am going to show over here. So this is the 3 criteria we are going to see. So based upon the FPGA. So first criteria, based on it, how it is going to work. This all things we are going to draw it, its architecture. So students, so we are going to design its architecture of FPGA. So that is nothing but Field Programmable Gate Arrays. So in that we are seeing this particular complete architecture. In that it consists of switch matrix. So switch matrix, what actually FPGA is going to do it. FPGA consists of switch matrix, configurable logical blocks, CLBs. So as you can see, CLBs, so these are called configurable logical blocks. So I'll write here configurable logical blocks. Okay, that is in the short we'll write it as CLBs. So what is the use of this configurable logical blocks? It's going to configure and it is going to provide the gate arrays, what gate arrays you're going to get the configurations. So that can be done by using this 4 types of CLBs. Next thing, it consists of switch matrices. What is the use of the switch matrix? It's going to give the interconnection between the vertical lines and the horizontal lines. So totally it consists of 1, 2, 3, so total 9 is there. So this is the 9 one. What about this thing? This is called IOBs. These are input output blocks. So everywhere, wherever is a switch matrix is there, wherever the line is there you need to write the IOBs. So this is nothing but input output blocks, which is going to give the input output interconnections. So wherever, in horizontal way, in vertical way, so wherever is there, see line is there, there is also there, then there is a switch matrix, there is also, we are going to give the input output blocks to complete our architecture of FPGA. Okay, so this is about input output blocks. Next thing, in order to provide this FPGA, it is also have a CLB, which already I said you, it is configurable logical blocks, and it provides a variety of local and global routing resources. Means it is going to provide the routing. Routing means from where your FPGA is going to get the route. Route means what? When you're going on a road map, so what is you are going to see? You're going to see a particular direction, right? Where you need to start, where you need to move, everything needs to be in a proper route. So same way, when you want to find out the direction for your gate arrays, so as I said, it is consists of a gate arrays is there. As soon as we are going to give a programming to it, based upon the programming, it's going to provide a arrays of gate. So from where, what's the route of it? So that is also there. Local and global routing map is also going to provide by using this FPGA. Next thing, it's going to do the programming and it's going to store the memory by using the SRAM, that is static random access memory. Based on that also, it's going to provide the buffers, that is input output buffers, and SRAM based configurable memories. Means whatever programming we are doing, it's going to connect based upon these SRAM. So what are the features we have seen, students? So we have seen it consists of SRAM, it has local and global configurable routes, that is nothing but routing. So routing is there. The next, the same thing, CLB it consists of switch matrix, then it has input output blocks. So these are the things which you need to understand in order to get the concept of your FPGA, right? So what I wrote, students, so these are the 4 to 5 things I wrote. One is SRAM, that is whatever the programming of this FPGA we're doing, it is going to configured by using SRAM. Next is local and global routing. So this is what is the use of this local and global routing. It's going to provide the routing of the input output resources. So for providing the resources, proper routing needs to be given. Next, CLB, that is configurable logical blocks. What kind of logics you want to provide, that can be done by using CLB. Then nothing but switch matrices. So based upon the switch matrix, from where you are going to give the varieties of the points, that is nothing but gates, you can get it by using the static matrices. Next, input output blocks, it is going to give the interconnections for whether it's going to be get the output from their particular switch matrix, or it's going to provide the input to that particular matrix. That is also going to be deals with this particular FPGA. Now it has 2 particular lines, students. So one is called horizontal line. So horizontal means the lines which we are drawing. See these lines, if I'm drawing like this, it should not get from this end. Little bit I'll draw the upper side, CLB. Suppose this is your CLB is there, the line which is going to get the interconnection. So these lines is called horizontal long line. If you want to draw the vertical lines between the switch matrices, so what is going to do? It is going to provide the vertical long line. What about this horizontal, this thing? This is your horizontal long line. Okay, so these are the 2 things we do have. One is the vertical long line, next is the horizontal long line, which is going to provide the connections of your CLB with respect to your logical functions. Okay, so this is the architecture we do have for FPGA. So in that, what are the things we have seen, students? So we have seen they are switch matrices. It basically, what is a FPGA consist of? It is a programmable field programmable gate arrays. So when you want to see the gate arrays, we have to do some logics to it, because what are the meaning of the gates? Gate means it can go for either 0 or it can go for 1s, right? So that particular thing we are going to get from the gates. We are not using a single gates, but we are using the arrays of gates. So provide the arrays of gates, we are using the particular architecture designed by the Xilinx. In Xilinx, what they have done, they have designed a system which consists of the switch matrices, which is going to give the switching phenomena, from where your input output is going to get the configurable, that is configurable logical blocks. There are 4 types of blocks we have taken for this pattern, that is nothing but by using the Xilinx. Next thing, it is also have the input output blocks. Based upon this, it's have 5 things to get into it. One is the memory. After doing any kind of programming, we need to get the memory to it. We want to store somewhere in the memory, so that is can be done by SRAM. Then it has routing resources. That is nothing but local or global, means when you write program, if you want to declare the variable before the header files, like you know that in C programming, when you want to write any variable out of the main, before the main if you want to write, it's a global declaration, right? So the same thing here also, when you have to the resources, that resources needs to be can be done by local or global while you are writing the programming to it. The same thing we can get with these CLBs. So this is a complete architecture in which the vertical long line is going to provide the interconnection of switch matrix to the next switch matrix. Horizontal also going to give the interconnection of IOB to the next switch matrix. This is the whole part of your FPGA architecture. So in which the basic concept what you have to see is how it is going to work, on what phenomena it is going to provide the input output block, and what is the use of this particular input output block. So this the basic architecture which we are going to learn in this is the particular thing, to make a note of it. And when you want to see the CLB, the main thing would be the interconnect resources, means how you are going to give the connection to these particular resources. That is going to be important part while designing this FPGA architecture. So each programmable IO pin has the programmable IO having the efforts for compatibility with different logical means. So what is the meaning of this? What I said just now, I said that when you want to write any particular configurable devices, that can be done by using these CLBs, because CLB is nothing but configuring. Configuring means you have different version of configurable devices. Out of that, as per these FPGA, which configurable device is going to be suitable for to design this FPGA architecture, that is going to deal with the CLB. Next, so this main thing is would be the designing of it. So the next is how it is going to provide the logical gate arrays operation. The meaning is that the first thing when you want to design this FPGA, that would be designed by using the Xilinx, which is the world first commercial FPGA, the design which already I said you in 1985 with the vintage of XC200 family series. What they said, there is a series they are saying that XC2000, this is a series they have designed. This is the world first one, the gate arrays what they designed by the Xilinx is with this. What is the feature of it? I just now told you it has 40k initial capacity of that would be the 40k gates arrays they can connect at a time. But as soon as this fabrication in embedded systems has been increased, so what they did, they improved this number that into 1,50,000. That number of gate arrays they even designed by using a concept called Spatron. Spatron is also one of the designing part of your FPGA. So that Spatron, the design with the family of devices which offers initially of 40k system gates, but today's Spatron 6 offers 1,50,000 logic cells plus 4.8 megabytes of block RAM. Means the RAM capacity of that particular block would be the 4.8 megabyte. So this are the capacities what they are saying MB. Okay, 4.8. That kind of memory site it is going to consist of, and it is going to store that particular number of datas into the FPGA. So students, so this is about the FPGA. We just want to take the next concept into consideration. Before it, you note down this FPGA and CPLD, both the architecture and the difference of both. What is the use of CPLD and how FPGAs differ from CPLD. Both the ways they can ask you, you should be in a position to attempt in exam and understand the concept. Attempting is not that a big thing. Thing is that how do effectively you can understand that particular concepts of the FPGA, right? So once again I'll revise it. FPGA and CPLD both are programmable logical device of sequential programmable devices, in which we have seen the CPLD, which covers input output blocks with PLD with programmable switch matrix. It is there, and the most important part what it has is it has a functional blocks, and it also has the gate arrays, right? Whereas the FPGA it is used in VLSI as a brand or a branch of ECE, that is VLSI, which is nothing but Verilog semiconductor of your ICs, integrated circuitry designing, which can program based upon the user location. Typically FPGA consists of arrays of millions of logic blocks. Based upon it is going to have the input and output connections, which is going to be configured by using CPLD. And the next thing, FPGA mostly consists of lookup tables. That is nothing, the lookup table it has multiplexer, gates and flip-flops. Basically what is lookup table? It is a truth table stored in an SRAM and provide the for combination circuit which has the logic blocks. So main realization of this logical gates of the combination circuitry can be done for SRAM by using the lookup tables. So this FPGA, CPLD and PLDs all are computer aided designing, means by using CAD tools. You people are already aware of these CAD tools, right? So based upon these CAD tools, it's going to provide the functionality of that particular device fabrication. So what are the things? I'm just saying you how it is used and where it is used, where actually you have come across this thing. It is a computer aided programming. That development tools is there. That is nothing but CAD tools, in which we are using FPGA, CPLD, all these things. We are going to take a different gates of arrays and we are going to get the response of it. How effectively it is going to provide the response to it by doing the CPLD and FPGA. So based upon these all types of parameters, we have seen the CPLD and FPGA. So FPGA mostly it is going to use in VLSI designing, which is having a branch of our EC department, which EC completely, if you want to go for designing of particular ICs, then we have to go for VLSI designing, in which we had different kind of concepts. CMOS is there, inverters is there. By using the PMOS and MOS, we have different kind of metal oxide semiconductor devices we had. Based upon it, it is going to be used in designing one of the feature of FPGA. Draw its complete diagram and then go with the running notes for this particular topic. So student, in the next class I am going to start the Mealy and More machine, which is the part of unit 5, in which how Mealy machine is going to be designed and how More machine is going to be designed. That particular part we are going to start, right? So this is about CPLD and FPGA. So in the previous classes we have discussed about these concepts, and even we have done with VHDL coding and everything. In the next class directly we are proceeding with Mealy and More machine. Okay, so that's it about today's class. Thank you.